All right, welcome to SIG-Apps, everyone. Today is February 27th. We have a fun agenda today. Just for announcements and housekeeping, there are some demo slots available in the next few weeks. So if you have something to show, feel free to throw yourself on the agenda. Our first demo is by the folks at Bitnami, Miguel. He is going to talk about the UI for the Helm charts repository. The repository that code lives in is called monocular, and I'll let him and talk about that a little bit more. Our second demo got canceled, and our discussion topic for today is Brian Grant sharing his thoughts on declarative application management. And after that, if you have any other items you want to discuss, feel free to throw it under the open discussion section or just bring it up at the end. And with that, I'll hand it over to Miguel.
Can you hear me?
Yep.
Okay. Give me a second. Okay, so you can see my screen. Great. My name is Miguel. I work at Bitnami. And today I'd like to show you a project that I and some other folks at Bitnami and Tails have been working on, which is called monocular. But before, just in case you're not familiar with Helm, Helm is a package manager for Kubernetes that works in a similar way than, let's say, Homebrew that you might have installed on your laptop, so you can do things like install WordPress, and you will have WordPress installed in your platform. And those applications, those apps are what are called Helm charts. And once you put those charts together and you publish them, is what we call a chart repository. So Monocular is an open source project that aims to create a web UI on top of these chart repositories. And its main goal is to help users to discover new apps, to discover new charts. You can think of it like an npm.js or Ruby-Gems kind of website, but for Kubernetes applications packaged as Helm charts. But before we get into it, I'd like to do a quick overview of the architecture so that way you can understand how it works. You can understand how it fits with some of the tools that are out there, and maybe you can get interested in contributing in the project. So simplifying Monocular will just takes information from the existing Helm chart repositories, indexes takes that information and that content and exposes it first via JSON API, and second as a web user interface. Assuming I did in this small diagram, what we have here is Monocular is based in two parts. One is a backend written in Go, and a front end written in TypeScript and Angular. So the box that we have at the top is represented track repositories. Today, Monocular supports or is configured by default to use the official track repositories, which are hosted in this Kubernetes/chart GitHub repo. So every 15 minutes, the backend, there is a process in the backend that every 15 minutes will take that metadata, that information, that things that change, new charts or new changes in versions, it will store that metadata in memory. Metadata like the name, the version, the description. But there are also some other kind of metadata, some other resources that require a little more effort to extract, like is the case of the README file or the icons that we need to process in to have the proper aspiration. So once we have that information in memory and in the disk, we expose that using a JSON API under /API/v1. API that has been created using a tool called Swagger, which basically means that we use the Swagger spec, and from that we created the code in the backend. Also, we have a web server, a web server to offer those preview files and icons. So having those two endpoints, we just have a front end, which is a single page application written in Angular and bundled next to a web server. So how does this look like once you run it? So it looks like this.
Hey, Miguel.
Yeah.
I hate to interrupt, but some people are having a little bit of trouble hearing. Is there any way, Ryan, is it just not clear?
I wonder if you have a microphone that's closer.
Yeah, you want to try using your Mac or your laptop mic?
Mm-hmm. Can you hear me now?
That's a little bit better. Can you say some more stuff?
Yeah, so if you can have the laptop mic unmuted and use that and keep the room mic off, that'll stop the echo we just heard and maybe make it a little bit more clear.
Can you hear me now?
Much better.
Okay, good.
You're a baritone now.
Was it wrong input?
Anyways, go ahead.
So do you want me to go back a little? Or yes.
If you could go back just like a minute or two, that'd be great.
Okay, so going back to, monocular, basically an interface on top of Kubernetes Helm charts, and the way that it's implemented using a backend and a front end. The backend getting information every 15 minutes from the official chart repositories and indexing that metadata in memory or in disk. Like a local cache, and that metadata gets exposed via a JSON API and a static web server that is part of the backend itself. And then we have a frontend, which is an Angular single-page app that it's bundled next to an Nginx web server. And so if you go to any running instance of Monocular, you will download the single-page app in your browser and start interacting with the backend. So that's the architecture, a simplified version of an architecture diagram. So how this looks like once you run it is this. Kubeapps.com is a running instance of Monocular that is configured to pull info from the official chart repositories. And as I mentioned, one of the main goals is to help users to discover new apps, new Helm charts. So that's why you can see that the messaging is more generic. We are talking about launch grade Kubernetes ready apps. We're not saying launch Helm charts. That way, what we're moving is the Helm chart process itself, or the Helm itself, as implementation detail in some way. So that's why we define it is bigger. People discover apps, and then we explain how to install it. So you have a search engine, a search input here, and then the list of apps sorted by name from both the stable and incubator repositories with the latest version shown there. So as you can see, there are many different apps. We have things like MySQL, we have applications, we have many different community apps, and then some information of how to contribute and who is behind this project. If you want to do a more advanced filtering, you can go to this like charts link, and here you can do filtering by repository. You can filter by when it was created. Let's go, for example, this one. So what you are seeing now is the information about a specific version of a chart. And what you have on the left is all the info. What are the prerequisites?
but it's inside that chart, how you install it, some configuration options, which is literally the README file you will find in the GitHub repository for this specific chart. And then on the right, you have the icon I mentioned that we need to process in the backend, the name, description, all this information coming from the metadata of the index itself. And the next box is the instructions, how to install, how to use this chart. And I think that this is very cool because in Helm, if you try to install a chart that is not in the stable, official stable chart, first you need to add that repository. And that's what Monocular is telling you here, that first you need to add the incubator repository and then how to install it. And as you can see, I put it here on the top, also tells you to install a specific pinning, a specific version of the chart. And talking about versions, we have here the different versions that you can actually swap. You can switch versions, tells you when it was released. And changing versions means that you get a new route up here that you can share with other people in case that they're interested in specific versions. You also get instructions on how to install a specific version. And even if you actually take a closer look, you will see that the README file changes. And in my opinion, this is one of the most interesting features of Monocular because sometimes you cannot install the latest version of a chart. So having an easy way to find the documentation of a specific version. I mean, usually this is not usually simple to do it today because you will need to either find the chart package and then get the README file, or go to the GitHub repository and go back in commit history. The fact that Monocular gives you this out of the box, I think it's very interesting. I really like it. And then we just have some extra information on extra maintainers and different sources. The last feature I would like to show you is search. There have been discussions on moving the search capabilities to the backend because today is a very simple client-side search. So moving it to the backend so other clients could use it, like CLIs that use this search, and also add more advanced query capabilities. But in any case, today it's functional, so you can search by name, you can search by keyword, or you can even search for maintainer. Yeah, by maintainer. So today on kubeapps.com or any other running instance of Monocular, there are 68 charts imported. And this is, as I mentioned in the diagram, this updates every 15 minutes. So any change that Anna and one of the other folks in the charts team make, it will happen here. So I recommend that you go to kubeapps.com and check it out. So going back to the repository, I would like to point out a couple of things. First, what if you want to contribute? And I personally encourage you to do it. So what if you want to contribute and you want to run this thing locally? So we have instructions in the README in which explain how to have very quick development environment for both the backend and the front end using a Docker Compose file. And what if you want to run it yourself? So we also have an article, a quick start guide that explains how to run Monocular in your Kubernetes cluster. And Monocular is packaged as a chart itself. So installing Monocular is as simple as Helm install deployment Monocular. And actually, if eventually Monocular ends up in the official chart repository, we will have Monocular inside Monocular, and who knows what will happen. But it's very easy to do it this way. And regarding the chart itself, I recommend you that you check out the code, because we have some cool stuff in that chart. We have things like a server-side rendering tier for like a pre-rendering engine for SEO purposes. We also rely on Nginx controller, and we also have configured that chart to support TLS, to have TLS support. So I recommend that you check it out. It's very cool. And if you actually deployed it and then you want to configure it with your CI/CD, we have a set of scripts also in the repository that are thin wrappers around Helm that might help you to do that. So here you have all the instructions of how to use them. And last but not least, I would like to thank everybody involved in this project. Special mentions to Jack Francis from DES, who led the backend efforts, my coworkers and Angel. And of course, the Helm and the chart repository, because without the tool and without the content, monocular obviously wouldn't make any sense. And please contribute, give us your feedback. We would like to hear from you. We have actually, go to the issues queue and you will find some interesting stuff that's going on. We have the pipeline features like configuring your own charts repositories or even being able to install charts, just clicking one button once you deploy monocular in your cluster. So if you think that this is interesting, could be good for the community, please go and let us know. I think that's everything from me. Thank you for your time, and I'm happy to answer questions.
First, let me say, this is Matt. Thank you. I've been longing for a user interface on top of the registries. I think this was fantastic. It makes my day to see this. It was great. Thank you very much. It does bring me to one question, though. Once you can search for things and find them, what would it take to go that next step and say, ooh, I click a button that lets me go install it into my repository? Is there anything out there that's talking about how do we take it from finding things and having Helm commands to the next step of installing from there? Is there any thought or anything in the roadmap for that?
So yes, there is. This is something that we have been discussing internally. So what if once you install, let's say that you install monocular in your internal charts repository in your cluster, and you configure your own Helm chart repository or using the stable one. The fact that we could connect to either be to dealer, to the Helm backend, or use a similar effort that some folks did in the dashboard to communicate with Helm itself directly. We think that that's possible, and that's what we'll offer an experience that I think is similar to what you were mentioning, which you will get to that WordPress details page, and you will have a button that says install, right? And that underneath will do all the magic. So yes, that's one of the features that we have in mind that will work, in our opinion, should work with another one, which is being able to configure your own charts repositories.
Sounds great. Thank you. You told me exactly what I wanted to hear. So that's fantastic. Thank you.
Any more questions for Miguel? I have a question. Miguel, what is, are there any plans to have badges on charts for what versions of Kubernetes are supported in the context of that chart?
I think it's a good idea. Okay. We actually haven't, I don't think that there is any discussion open about that specifically, but please create the issue in the Helm monocular repo and we'll talk about that. I think it's useful. Compatibility is something very important.
Okay, cool. And awesome job on the quick start guide. This is such a great example of an application that runs in Kubernetes, and it's nice to see that.
Thank you.
Awesome. And another question, if someone's really interested in contributing, are there any areas that you're looking for active help in right now?
Well, I mean, the project is actually in a very early stage, so help anywhere will be needed from the backend to be sure that it scales properly once you add more than 2 repositories, or if the current repository is a stable one and the incubator keeps growing, nor the API nor the front ends are ready for that. the front end, as you just mentioned, a feature that could be interesting, which is compatibility showing you the minimum requirements. We need to make some efforts in SEO because we want people to discover charts via monocular, but we haven't spent much time actually in preparing the application for that. So in the front end, we have a ton of work that we need to do, including that feature that Matt mentioned. In the back end, we have a ton of work to do, from optimizing the back end to maybe create another adapters for another kind of repositories. There are a lot of stuff that is needed. So both front end and back end are more than welcome.
Okay, cool. And I have a third question, if that's okay. What if I have a repository that I maintain, and I want that to be a part of kubeapps.com? Are there any plans to integrate like additional repositories, or is this just for the Kubernetes official and incubator repos?
I mean, personally, I don't know. I think in some way, I believe that it would be good to have one place that has as many apps as possible, so people can find quality charts regardless of from where they're coming from. But I don't know. Let's open the discussion offline. I would like to hear the opinion on the official charts maintainers and see exactly this case how those charts look like, if they have enough quality for being next to them. I mean, coming back to what do we need to do in the front end, probably before we add more charts there, we might need to implement some features to mark some charts as official and to be sure that we can have a huge amount of content, but that content can be easily differentiated by content that has been curated and content that hasn't been curated. So it's early, but open an issue in GitHub and let's discuss. I think it's a very good idea, and I don't know if we are ready yet.
Okay, thank you. Does anybody else have questions for Miguel? All right, I think silence means the most. So thank you so much for your demo. Really excited for kubeapps.com and the future of monocular. All right, so next up is Brian Grant. Brian, you ready to talk to us about declarative application management?
Yeah, let me share my screen.
Okay.
Can everybody see that while it's loading there?
Yes.
Okay, so I'm going to talk about declarative application management. I previously wrote a doc that some people may have seen, white box, common off-the-shelf application management. This content is mostly taken from there. There have been a number of tools, Helm included, which provide some degree of declarative application management in Kubernetes, but it still feels like there are gaps. So I want to talk about a solution that's inspired by a number of partial solutions I've seen in this space, and maybe try to drum up some interest in filling the gaps that exist. So yeah, the problem statement is I think Kubernetes still lacks end-to-end tooling for declarative application management. By white box, I mean that the user can see and understand the configuration of the application and all the Kubernetes resources involved. And that's to distinguish it from black box, where it would just be opaque and they might not know anything about the underlying implementation. So I have a few requirements in mind. And I'm going to talk about most of these in subsequent slides. I'm not going to talk about too much of them here, except that I'm going to point out that however, if someone writes a YAML or however they express the declarative configuration of the Kubernetes resources and of the application, it still needs to leave space for automated processes to do some amount of automatic configuration. The simplest, most common example of this is horizontal autoscaling, where you want the number of replicas of your deployment or replica set or replication controller, what have you, to be automatically controlled by an autoscaler. But there are lots of other cases as well. We encourage people to write controllers that do things automatically to Kubernetes resources also. So whatever solution we come up with needs to allow for that and not have the declarative configuration conflict with automation and vice versa. So the first requirement is that it needs to be possible, and more than possible, it needs to be easy to manage the declarative configuration under version control. Configuration is typically human authored and should be human readable. So that's very different than binary build artifacts that you think of for traditional packages that are stored in a package repository, which are the output of some complex build process, and no one's going to disassemble them and read the assembly code. That's just not useful. You know, if you write a deployment manifest or service manifest or a config map, you know, you're expected to be able to read that and understand it. And configurations will get more complex over time. You know, the OpenStack Helm charts are a great example of this, but it's still, you know, to some degree, you can dig in and understand it. Also, you know, when the human is expected to be writing, reviewing, changing configuration, that's very different than an automated system like an autoscaler, in part because if something changes, the timescales involved in noticing that something has changed and responding to that change is very, very different. It's not like an autoscaler which continuously observes the current state and rapidly takes corrective action. So if you like blow away the number of replicas, an automated process could potentially repair that very, very rapidly. Whereas, you know, if a human has to go recreate it, they might not understand what the configuration should be. It will take them some time to figure that out. So keeping the configuration safe and discoverable and understandable are all pretty important for those sorts of scenarios. Keeping configuration in version control is considered the industry best practice, industry-wide best practice in all kinds of areas, whether it's Chef or Puppet config or your Nginx config or whatever it is. Just people have decided that that is a good approach to take. It provides a familiar workflow for making changes and controlling the changes, reviewing the changes, auditing the changes. You can revert changes pretty easily using standard version control tools. If you need to reproduce the same configuration again for testing or in a different cluster or something like that, then again, that's a pretty straightforward thing to do by running off the same configuration or by cloning it or forking it, branching it, etc. So I think, you know, this is how Google manages all its configuration for Borg internally under version control. And as I said, you know, it's done in many other scenarios industry-wide as well. So just sort of a brief aside on customization, you know, obviously for configuration to be reusable, it has to be customizable. The same configuration doesn't work for everybody in every different scenario, especially even if the same person or team is instantiating multiple different instances of a configuration. Those different instances typically need to be customized in some kind of way. The most typical approach that people take is parameterization. And you see this in OpenShift templates, you see it in Helm charts, you see it in pretty much every configuration system that exists. And it's super useful for a small number of choices, especially things that intuitively make sense about the application, like if you need to provide the name of a database table or something like that when you instantiate a database. You know, that's just something that's kind of makes a lot of sense and doesn't get too much into the weeds of the implementation. But these parameters must be machine discoverable because there are a lot of scenarios where we want to be able to populate those parameters automatically, not just by hand editing some kind of file with a human readable, writable syntax. And they need to be self-documenting. For example, one thing that you see in OpenShift is that it will automatically pop up forms for templates showing you what the parameters are and providing some kind of short description of what they are so the user can understand what values they need to populate. That's going to be more and more useful. I'm going to mention the service broker later, but once we have service brokers for things like Helm and other solutions, that's one example of where parameters need to be automatically surfaced. But it would also be super cool if the command line tool could query the user for parameters to fill in, so that they don't actually have to go find a file and read it and figure out what values they need to provide. Into one. So a common scenario, again, as I said, is people want to instantiate the same configuration in many contexts. So the structure of the configuration needs to lend itself for that. Like in the Helm case, an example would be providing multiple files full of parameters for a single chart. You can clone the whole thing, but people have a resistance to doing that. There's an inherent desire to specify things only once that need to be specified once. While you could diff multiple different copies of a configuration against each other to keep them in sync, that's a lot more tedious than just keeping one copy. And then, finally, just like you want to version control the parameterized templates, you want to version control the parameter values as well, typically. So not just necessarily providing them on the command line, although you could check in a script that specified the values on the command line, but people really want a declarative file checked in under version control so they can manage it the same way as they manage the templates. But then there are also many other customization strategies. Parameterization is not the only one. And you can see parameterization becomes much less attractive in certain scenarios. If anybody has taken a look at the Mesosphere universe packages, some of those packages have dozens or even hundreds of parameters because they not only specify every parameter that is needed to customize the configuration for Marathon, but also the application itself. So every application parameter gets mirrored in Mesosphere universe package parameter. And with that sort of scenario, parameterization starts to lose its appeal pretty rapidly. It becomes very complex. It becomes a whole nother language effectively you have to document. That's different from the documentation of the API of the system. Is different from the documentation for the configuration of the actual application. So other approaches can complement parameterization. One that's super common in the Kubernetes community is just forking. Forking, if you just have unparameterized YAML files, that's effectively what people do. They pick up example YAML files from somewhere on GitHub, fork them, change the parameters that they want to change, and go from there. And actually that makes it pretty easy if you maintain those changes as a set of patches to rebase, which creates a natural update flow. And it allows you to make pretty much arbitrary changes without customizing every single little thing in the template. Like if you can imagine needing to potentially set every single parameter of the pod spec in any given deployment config, you don't want to actually add parameters to every single template to permit that, especially for uncommon kind of changes. Forking works much better. Some kind of patch or overlay mechanism, KPM, I believe, provided some sort of patch mechanism. It's similar to forking without actually forking. Specifying a patch against an API resource can work. We've actually had previous config projects internally to Google that were shut down that attempted to provide stacks of patches that you could apply, and this is also being discussed with respect to ways to extend kube control apply. It gets pretty complex pretty quickly, and similar to Docker image layers, if you change one of the base layers, it invalidates all the layers above. So that creates some fragility that can be really hard to manage. So patching works well, I would say, in fairly general purpose patching works well in restricted cases, but you have to be careful. Generation can be good, really useful for static decisions. I'm a big fan of this, and I think we could build a lot more tooling in this regard. For example, if you're building a Java application and you need to set certain parameters with respect to the JVM, there have been some tools to do this for, outside the container space, especially for platform as a service scenarios, but also I think the successor to Vagrant did some amount of this when that was still being developed. But looking at the application and automatically generating some configuration can make a lot of common cases a lot simpler, and works very well with the rest of the whole flow if you just do it on the front end and use it to fill out a bunch of boilerplate. Similarly, composition. This is where I think a better approach to changing application-specific parameters is to just provide a way to plumb the whole application configuration in, as opposed to reparameterizing every individual field of the application configuration. And config map and secrets are intended to permit this in Kubernetes. So you can potentially provide a whole config map to an application rather than plumbing those individual parameters out. Automation, again, autoscaling is the most horizontal autoscaling is the most common example of this. If people aren't aware, and in the community repo, there's a proposal for vertical pod autoscaling. I think that would be a super useful tool, so we don't have to expose CPU and memory parameters for every Helm chart, or provide like small, medium, large T-shirt size kinds of separate templates for applications, regardless of what the templating scheme is. And then finally, transformation. If you look at the OpenShift templates or the Helm charts, the vast majority of parameters are just customizing resource and label names, resource names and label values. I think things like that, we can just automate a customization strategy that actually understands the Kubernetes resource format, because that format is ubiquitous and stable. So I also think, coming up with some common conventions is already happening within the Helm chart repository for what labels we recommend will simplify things, especially for new users. So I'm a big fan of domain-specific transformation, either in the client tool or, increasingly in the server. There's another proposal that was just merged for, I think it ended up getting called a pod preset, to set things like default environment variables for pods that match a label selector, right? So those kinds of things will enable additional transformations without, again, requiring parameterization of every little thing that someone might want to customize. And one of the big reasons why parameterization breaks down at scale is because there are lots of different kinds of configuration that people want to provide at different times. So parameterization ends up also being not very composable and not very robust when people want to make these additional changes. Like the names and labels are the most prevalent example today, but also if people want to do dependency injection to change something about some of the components that are part of the application, or they want to customize additional parts of the application configuration, or change rollout constraints. Again, operational parameters like the number of replicas or the compute resources like CPU and memory are very commonly need to be customized depending on the workload of the actual running instances. I won't go through all of these, but some concerns are known at development time when the application is written and when the configuration is written that's going to be shared. But a lot of things really depend on the context in which the application is deployed. And having a mechanism where you can easily add those, the additional configuration you need without forking or parameterizing the core is an approach that's going to scale better. So, as we develop this, there are some key kinds of automation that the mechanism needs to integrate with. I mentioned the service broker earlier. If people aren't aware, there's a service catalog effort trying to provide a service catalog based on the Open Service Broker API that was spun off as an independent project by Cloud Foundry. The Service Catalog SIG has been working on that, and Deis already has a Helm-based service broker, and there are a few other prototype service brokers that exist. Other most common things people are going to integrate with are their continuous deployment system, for their own application building and deploying, a GUI for deploying applications, for people who are new to the system typically. And in production, I don't really see people managing applications through a GUI, but it is a great demo mechanism and a great way to learn the system. And then again, other effective configuration like secrets and application configuration that sometimes needs to be generated to compose together application-specific parameters and environment parameters. Since most of the applications weren't designed to be cloud native and have a lot of parts of the environment dynamically change. So universal, what do I mean by that? There are a lot of different dimensions where we want the declarative application management mechanism to apply. For sure, stateless applications, which a lot of platform as a service systems have traditionally focused, but also stateful applications, other classes of workloads. People want to use, I believe, the same tools and workflow for all the different kinds of applications, at least the core of the workflow. Maybe they need additional components in some scenarios or for some types of workloads, but at least for the core, they don't want to use totally different tools and have a totally different experience for different applications they need to deploy. Built-in APIs and extensions. So for some systems like Docker, Compose is a good example of this. If you create a configuration language that is different from the API, that creates a burden to actually extend it for the additional kinds of APIs that get developed that you might want to express some configuration for. And the really hard case, I think, is extensions. Kubernetes, we're trying to make more and more extensible to facilitate more custom automation by its users. And those things will be difficult to express in a manually designed configuration language that's different from the API mechanism. Bespoke and off-the-shelf apps. So bespoke apps is what I call applications that people write themselves, and off-the-shelf is things more like the existing Helm charts where there's an existing application that people just want to run. Bespoke applications are, most people have to run combinations of both, right? They have their business logic and their own stateless front end, for example, is the canonical scenario, and then the infrastructure tiers for caching, storage, etc., are off-the-shelf components. I think people would like to use, again, the same tools and workflow for both cases, but for the bespoke application, they might want some help getting started generating the Kubernetes configuration rather than having to copy-paste the YAML from somewhere else or write the whole thing from scratch by hand. So I think there are some tools in the space, for example, OpenShift's new app command, kubectl run, help with this a little bit, but they're not really designed to plug into a declarative configuration workflow where you would generate the configuration and maybe customize it and then check it in somewhere. I also think, the same core tools and workflow can serve both beginners and power users. The beginners would just need more tooling to help them get started from some kind of generic templates or examples, and then as they want to grow into more sophisticated deployments with canary deployments or what have you, they could customize their configurations as needed. And then, the same tool should work on the laptop and in production. But, if you're just iterating on your laptop, you might not want to have to check in every version of the configuration files to retest it. So,
Brian, I wanted to make a comment real quick.
Yeah.
So I think the point you were making about generation is in most cases, I think it's extremely valuable for people to think about generation, any kind of flow that ends up creating declarative config, how we help people go back to higher level declarative configs out of that. So new app, Helm charts, if you have a particular version of a Helm chart, tools and patterns that help people take those and turn them back into generic templates of whatever form they are is also really important, because inevitably new users start doing things like iterative, imperative style generation, and then down the road we want them to be able to do declarative. So I think it's a really important distinction.
Yep, I agree with that. I have a picture on the next slide, I think, where I'll talk about where I see that fitting in. So again, API-based, I think because we need it to work for all the Kubernetes resources, for extensions and so on, whatever schema is used for configuration in the general case, I think there are some specialized cases where things like the Compose tool, which generates Kubernetes configurations from the Docker Compose format, can be useful. But if you want to use or potentially grow into the full power of Kubernetes, what the configuration schema needs to be the literal API schema, as we predominantly use in the Kubernetes ecosystem so far, or at least automatically derived from it. For instance, saying we're trying to generate the open API specification with greater and greater fidelity. That someone from Puppet had demonstrated generating a Puppet-like schema from the Swagger spec. So something like that could work. If you maintain it by hand, it doesn't work for extensions, and it is hard to keep up with the pace of API evolution. So in my experience, again, anything by hand just isn't going to work. But it doesn't actually have to be the literal API schema, although, so I guess another example would be if you want to write configuration in using a Fluent style API like the Fabricate Java client library, you could potentially do that. I think the configuration needs to be versioned according to the API versioning. Again, I need to keep up with the rate of API development and extensible as the API is extended. I also foresee the API schema serving as an intermediate representation, both on the client, before creation of the resources, and after the resources have been created, being modified at runtime by active control loops. This is something that is much harder to do if you're not using the literal API schema, or if the API is transformed significantly by some kind of macro preprocessor that's not domain aware. Like Jinja is an example of this, where YAML is not even properly necessarily preserved if you Jinja templates in the incorrect way. But if you're going to do any kind of transformations, it's super helpful to just use the literal API schema pre-creation or post-creation. And the admission control extensions that we're working on are intended to facilitate more post-creation transformation before resources become active. And that's what's going to really enable powerful composable transformations of API resources in a way that can be customized for all different contexts. So we have been working on kubectl apply as a way of enabling declarative intent to be composed with automatically set attributes. The way kubectl apply works, if people aren't familiar with it, is it keeps track of the configured state. So as the user changes the configured state, those patches can be applied to the live state, but the anything was never specified by the user is not considered to be under the domain of the configured state, and the runtime state doesn't get trashed by the tool. So if we just do kubectl replace, that sets everything. If there were dynamically set values by some runtime automation, those values would get trashed. So eventually I would like to actually move support for apply into the server and make the configured state part of the API. Make this work for all clients, but for various historical reasons, it's currently done in the client. We're trying to fix the bugs that exist in kubectl apply. But I see this as an approach to synchronize state between different layers of APIs, many places in the system. For example, if we ever do in-place updates in deployment or one of the other workload controllers, I would imagine we'd be using this. We already have discussed doing this, using this approach for daemon set to figure out what changes have been made or whether changes have been made to the template. And if we create any kind of template resource similar to the OpenShift templates in Kubernetes, I would expect to use this approach to synchronize between changes to a template and the instances of the resources instantiated from the template. So just finally, I think it's important to decouple the generation and transformation steps from orchestration of creating resources and what I call reconciliation, which is just taking the declared configured state and synchronizing it with the live state in the server. And that's because these pieces are generally independently useful in many different scenarios. And I don't want to get in a situation where people feel compelled to use a certain tool or workflow just because it provides the one piece of functionality that they really need. We had that problem inside Google in its configuration system, and it led to all sorts of crazy scenarios where things were a lot more complex than they needed to be. So this is why we've tried to keep kubectl working just on vanilla API resources, for example. So it can just do the bare bones reconciliation step with the server, and more complex tools can be built on top of that. So the flow I have in mind looks like this. So, regardless of whether it's a bespoke application or an off-the-shelf application, people are starting from scratch, or you're instantiating an application that is widely used. I imagine the configuration they start from will be some kind of commented set of configuration files and some Git repository somewhere. And then we can provide tooling to discover those applications. Monocular looked great for discovering home charts. Is just one example. But we can provide some kind of tooling for finding the right starting point. But I envision the first step they'll do is they'll fork it from the Git repository and transform it through a combination of automatic tooling, customizing super common things, like names and labels or what have you, and maybe editing it by hand, both the raw templates and whatever parameter values are expected to be used. And the reason for a fork in that step, especially if it's an off-the-shelf application, is, again, that will make it easy for them to maintain patches so that they have some reasonable way of consuming updates. But if I were using any kind of off-the-shelf template, I would definitely fork the thing as the first thing I did, and not just run off of templates in, even if I didn't plan initially to change anything, there's always the potential to need to change parameters later. Again, especially things like operational parameters, if you don't have automatic system for doing that, or even simple things like how the probing interval for a liveness probe or something like that. The need to fork in real scenarios is extremely, extremely common. So I just do that first, make it easy to maintain patches. And then check in the configuration into my own repository somewhere, not the same as the code repository, but check into my own repository so I have control over it. and then automatically reconcile with the Kubernetes cluster from that. Box wrote about this in their blog post. They have an automatic applier. I could easily see, creating some kind of resource, a third-party resource or whatever, to point at a Git repo and then have that Git repo constantly automatically applied. And then once it's created, again, post-creation, I think we need more controller-based transformations. The admission control extensions are one example of this, to allow administrators to plug in their own custom policies, whether it's scheduling pods to dedicated nodes or whatever it is they want to do, like the pod presets for injecting environment variables or volumes. But those post-creation transformations, I imagine, are going to simplify the configuration that users have to write by hand. So this is the basic work flow, data flow I have in mind. The additional tooling or transformations I imagine to be at the first step at the bottom left. And if we need to build tools to also generate or factor, add parameters to configuration or something like that to make it easier for people to build templates from configurations they're running from, I'm all in favor of that as well. But yeah, any custom generation or things like that, I imagine to be at the beginning of the flow. And then otherwise, the flow through the rest would be the same. So that took a little bit longer than I expected, but I'll hope there's a couple minutes for questions if people have questions.
Hi, this is Matt Farina. I have questions.
Yep.
Of course I do. So I know you talked about in the workflow here, even on this last slide of, I find another configuration and then I fork it and I check it into my own. That's one of the possible roads. But I know another road that folks like to have is to say, okay, I'll start with maybe my configuration file and I'll declare my parent and then I'll declare just my override values might change. Maybe my parent, I say, okay, my parent at this version or this version range, right? So you got versioning in there. And then I can say, okay, here are my override parameters for that. Now go deploy it. And your tooling go fetch the parent from wherever it's at, know that, apply the differences, and then use that state rather than forking it. It's a different style workflow than this Git workflow. What do you think of something like that in this flow as well?
Yeah, well, first of all, I'll just say I believe people should be able to do whatever works for them. Mm-hmm. I have to say that people do exactly what you suggest inside of Google, and I've seen it gone horribly awry. The reason I recommend forking is the first thing, again, is to just provide that additional level of control, right? That you have control over how you consume updates and additional, like imagine you have a production emergency and you have to change some parameter that was not not parameterized in the specification you consumed from the original source. Then you'd have to go fork it at that point, and that's a lot riskier than having your own fork that you have control over. Or another scenario is, if like the whole business with Docker tags, right, where people push additional images at the same tag. If that is a possibility where the version you're depending on can change without your awareness, that could potentially put your production deployment at risk. If you want to actually review what changes are being made when you're doing a production deployment, it makes that more complex. So, I think for development, I can understand why people might want to do that, but I personally would not recommend doing it in production.
Yeah, and it comes down to also, where are you getting it from? Is your parent a public one, or is your parent an internal one because you're running 4 or 5 instances of the same application and your parent is something that you control somewhere? I think there's a lot more complexity to this workflow and the way that people carry it out. And so I definitely understand and respect the fork it and carry it, and then carry those patches and deal with those updates. And I even understand the complexity that it can come with automated tooling to help you carry those updates and review it. We've done that too. In fact, I've done both ways over the course of just the last 5 years. And so I've experienced the positives and negatives to both sides of the equation. It's more of the idea of having that freedom built into the flow to do some of these things, so both sides are enabled. And that's kind of where I am asking this question, not so much to say you should do one over the other. I think people can make their own business decisions. At least it's good to convey the positives and negatives of both, but to enable that freedom.
Sure. Yeah, I'm all in favor of freedom.
And then the other question that I had was more, if I were going to use Helm today in a CI/CD workflow, what would need to change to enable maybe the idea of your philosophy here to work?
Well, I think people could fork the chart repository, right? It's a little bit because of limitations of Git and GitHub. It's a little bit inconvenient to do so. I'm actually getting kicked out. But you could potentially use it in this fashion. I think if you want to instantiate charts in multiple different contexts, I don't think the values file chart structure is really set up to facilitate that. So I think there's some minor tweaks that would need to be made.
All right. Yeah, you're getting kicked out, so I won't keep you longer. I'll be respectful of the next person. I'll take this to the mailing list, if that's all right.
Okay, yeah. And by the way, if people want access to the slides, just join SIG-Apps or Kubernetes Dev, and that should give you access.
Thanks so much, Brian. We'll continue this on the mailing list. Thanks, everybody. We're 2 minutes over, so I'll let y'all go. Have a great week, and see you next week. Bye.
Bye-bye.
Bye-bye.